When seeking to purchase 12/5 tray cable type TC in length shorter than a full spool, several options are available. Firstly, consider online retailers. Websites like Zora offer Southwire MC cable in 100-foot rolls. Granger provides TC tray cable, also with a 100-foot minimum and may be cut to length. Amazon Business is another online retailer that offers cut-to-length options. Secondly, explore local electrical suppliers. Calling or visiting local electrical supply stores in the area is a good strategy. These suppliers often provide cut-to-length cable services. Thirdly, investigate custom cable manufacturers. Companies such as Belden offer TC control cable with custom lengths available. Leviton is another manufacturer that provides cut-to-length options. Keep in mind that the price per foot is typically higher when purchasing cut-to-length cable compared to buying a full spool. Also, note that some retailers might have a minimum order quantity. Always verify with the chosen supplier that they carry 12/5 TC tray cable and can supply the desired length. Tray cable, or TC cable, is a multi-conductor cable approved for use in cable trays. Cable trays are support systems that provide a safe and organized method for routing cables. TC cable is designed for industrial applications and is often used for power, control, and signal circuits. The 12/5 designation refers to the cable's construction. The 12 indicates the American wire gauge, or AUG, size of the conductors. The 5 represents the number of conductors within the cable. In this case, it signifies that the cable contains 5 12 AWG conductors. The American wire gauge system is a standardized system for designating wire sizes. Lower AWG numbers indicate larger diameter wires. Larger wires have lower electrical resistance and can carry more current. 12 AWG wire is commonly used for 20 amp circuits in residential and commercial wiring. Each conductor within the 12/5 TC cable is insulated to prevent electrical shorts. The insulation material is typically a thermoplastic or thermostane polymer. Thermoplastic insulation softens when heated and hardens when cooled. Thermosetting insulation undergoes a chemical change when heated, forming a rigid, cross-linked structure. TC cable is also jacketed with a protective outer layer. The jacket provides protection against abrasion, moisture, chemicals, and sunlight. The jacket material is usually a PVC or polyethylene compound. PVC, or polyvinyl chloride, is a widely used thermoplastic polymer. Polyethylene is another thermoplastic polymer known for its flexibility and chemical resistance. TC cable is designed to be installed in cable trays without the need for conduit. Conduit is a rigid or flexible tube used to protect and route electrical wiring. The use of cable trays and TC cable can simplify installations and reduce costs compared to using conduit. TC cable is typically rated for 600 volts. This means that the cable is designed to safely carry voltages up to 600 volts. It's essential to select the appropriate voltage rating for the application. Using a cable with an insufficient voltage rating can be dangerous. When installing TC cable, follow all applicable electrical codes and standards. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. Article 392 of the NEC covers cable trays. Article 336 covers TC cable. Proper support and securement of the cable are essential. Cable should be supported at regular intervals to prevent sagging and strain. Cable ties, clamps, and other hardware can be used to secure the cable to the cable tray. Ensure that the cable is not bent excessively. Exceeding the cable's minimum bending radius can damage the conductors or insulation. The minimum bending radius is typically specified by the cable manufacturer. When terminating TC cable, use appropriate connectors and terminals. Properly terminate all conductors to ensure a reliable electrical connection. Inspect the cable regularly for signs of damage. Replace any damaged cable immediately. Damaged cable can pose a safety hazard. When purchasing TC cable, consider the environmental conditions in which it will be used. Some cables are designed for specific environments such as wet locations or hazardous locations. Select a cable that is suitable for the intended environment. Consider the temperature rating of the cable. The temperature rating indicates the maximum operating temperature of the cable. Choose a cable with a temperature rating that is appropriate for the application. When installing TC cable in cable trays, maintain adequate spacing between cables. This helps to prevent overheating. Follow the spacing requirements specified in the NEC. When running TC cable through walls or floors, use appropriate sleeves or fire stops. This helps to prevent the spread of fire. Ensure that the cable is properly grounded. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse. This helps to protect against electrical shock. When working with electrical wiring, always de-energize the circuit before making any connections. Verify that the circuit is de-energized using a voltage tester. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Never work on electrical wiring when you are tired or distracted. If you are not comfortable working with electrical wiring, hire a qualified electrician. Working with electricity can be dangerous. Always follow safe work practices. When selecting TC cable, consider the ampacity of the conductors. Ampacity is the current carrying capacity of a conductor. Select a cable with an ampacity that is sufficient for the intended load. The ampacity of a conductor depends on its size, insulation type, and installation method. Consult the NEC for ampacity tables. Table 310.15b16 in the 2020 NEC provides ampacity ratings for conductors based on insulation type and temperature rating. For example, a 12 AWG copper conductor with THHN insulation and a temperature rating of 90 degrees Celsius has an ampacity of 30 amps when installed in a cable tray. However, the ampacity must be adjusted for ambient temperature and the number of conductors in the cable tray. When multiple conductors are bundled together in a cable tray, their ampacity is reduced due to heat buildup. The NEC provides adjustment factors for ampacity based on the number of current carrying conductors. Consult the NEC for these adjustment factors. When selecting TC cable, consider the voltage drop. Voltage drop is the decrease in voltage along the length of a conductor. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Voltage drop depends on the conductor size, length, current, and power factor. Use a voltage drop calculator to determine the voltage drop for a particular circuit. Increasing the conductor size can reduce voltage drop. Using copper conductors instead of aluminum conductors can also reduce voltage drop. Copper has a lower resistance than aluminum. When installing TC cable, avoid sharp bends or kinks. Sharp bends can damage the conductors or insulation. Follow the manufacturer's recommended bending radius. When pulling TC cable through cable trays, use a cable pulling lubricant. This reduces friction and makes it easier to pull the cable. Avoid pulling the cable too hard. Excessive pulling force can damage the cable. Use a cable pulling grip to distribute the pulling force evenly. When splicing TC cable, use appropriate splice kits or connectors. Ensure that the splices are properly insulated and protected from moisture. Follow the manufacturer's instructions for making splices. When terminating TC cable in electrical equipment, use appropriate terminals or lugs. Ensure that the terminals are properly tightened. Loose connections can cause overheating and equipment failure. When installing TC cable in hazardous locations, use explosion-proof fittings and enclosures. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Follow the requirements of the NEC for hazardous locations. Article 500 of the NEC covers hazardous locations. When installing TC cable outdoors, use cable that is rated for outdoor use. Outdoor cable is designed to withstand exposure to sunlight, moisture, and temperature extremes. When installing TC cable underground, use cable that is rated for direct burial. Direct burial cable is designed to be buried directly in the ground without the need for conduit. When installing TC cable in corrosive environments, use cable that is resistant to corrosion. Select a cable with a jacket that is made of a corrosion-resistant material. When installing TC cable near sources of electromagnetic interference or EMI, use shielded cable. Shielded cable has a metallic shield that helps to block EMI. EMI can interfere with the operation of sensitive electronic equipment. When selecting TC cable, consider the color coding of the conductors. The NEC requires specific color codes for different types of conductors. For example, the grounded conductor, or neutral, must be white or gray. The equipment grounding conductor must be green or green with a yellow stripe. The ungrounded conductors, or hot wires, can be any color except white, gray, or green. Following the color codes helps to prevent wiring errors. When purchasing TC cable, ask for a certificate of compliance from the manufacturer. The certificate of compliance verifies that the cable meets applicable standards. Keep a record of all cable installations. This record should include the cable type, size, length, and installation date. This information can be helpful for future maintenance and troubleshooting. Regularly inspect TC cable installations for signs of damage. Replace any damaged cable immediately. Damaged cable can pose a safety hazard. When disposing of TC cable, follow local regulations for recycling or disposal. Some cable materials may be hazardous and require special handling.